In Amsterdam, this elite team of engineers is embarking on an epic endeavor. They're attempting to build a remarkable new hotel that floats in thin air.
This is the type of building that can go horribly wrong.
When complete, the hotel will be the largest in the Netherlands.
People who saw the design simply didn't believe that it was possible.
To build this colossus, the team must battle unstable ground.
A big sinkhole could appear. That could be a disaster.
Terrifying heights and limited space.
Oh.
They are pushing to complete this ambitious design in just 38 months. This incredible hotel ranks in a league of ambitious new engineering wonders that are bigger, faster, taller, and more advanced than anything ever constructed before. This is the inside story of the extraordinary challenge of building these giants. Amsterdam, in the Netherlands, famous for its historic architecture and network of canals. By 2030, more than 31 million tourists are expected to visit this iconic city every year. But the city simply doesn't have enough hotels to accommodate so many people. To keep up with demand, developers have an ambitious plan to build the largest hotel in the country, right in the heart of the city. They've chosen a plot in the up-and-coming Zuidas business district. But it will be a tight squeeze, with only 50,000 square feet to spare. It will be sandwiched in between two main roads, with an underground subway line running right alongside. The difficult site poses a huge challenge for the hotel's lead architect, Renier de Graaf.
It is a very small triangular piece of land, and we couldn't do a normal hotel because a normal hotel is a big foot and the tower with rooms on top of it. In order to be able to make a project here, we literally had to turn the traditional idea of a hotel on its head.
The tiny site forces Renier and his team to come up with a groundbreaking and unconventional design. 3 enormous triangular sections stacked on top of each other make up the body of the hotel, maximizing floor space above the crammed plot. An offset central section draws the eye to massive 80-foot overhangs, where the buildings seem to float in midair. 2,600 sheets of specially insulated glass coat the exterior. The hotel's bold design continues inside, where designers furnish each of its 650 rooms according to the compass point they face. Inside and out, this unique hotel is a masterpiece of modern design. Constructing this giant on such a tiny plot won't be easy.
The project pushes boundaries to the point that upon first glance, many of the people who saw the design simply didn't believe that it was possible. It is quite a tour de force.
Building this iconic hotel involves a series of unique engineering challenges. First, they dig out a huge 260-foot diameter hole, just 1.5 feet away from the city's subway line. They must reinforce the foundations with steel and concrete, then build a super strong reinforced concrete pillar to form the building's core. Around this, they construct the 3 huge triangular prisms, each one offset from the last by 60 degrees. they reinforce the vast overhangs with massive concrete columns that support the core and attach to the main pillar. To seal the building, they bolt 2,600 glass sheets onto an external aluminum frame. They have just 38 months to build what will become one of Amsterdam's most iconic buildings. Construction begins in autumn of 2016. Chief Foreman Nick Timmer is responsible for bringing Renier's gravity-defying design to life.
It's a nice design, but that's all theory, and now we must also make it in practice. So yeah, that's a very big thing.
Before Nick can tackle the main building, he must first construct the vast foundations that will support the massive weight of the hotel. The sandy ground below Amsterdam makes this a challenge in its own right.
You can't build on ground like this. When you have rock, it's possible to build, but Amsterdam is very soft grounds. It's not good ground to build on.
To create foundations strong enough for the hotel, workers remove 2,500 truckloads of this soft, sandy ground. This is a risky operation. If the sides of the construction site collapse, they could damage the nearby highway and subway line. To prevent this, Nick and his team devise an ingenious solution. First, the team excavates the whole site 2 stories below ground level. They line the sides with corrugated steel sheeting. To compensate for the soft ground, the team drives in 575 thick steel pillars called piles, packing them most densely around the building's core. Each pile must penetrate an astonishing 75 feet deep through sandy upper layers to the more solid ground underneath. Finally, they install giant steel beams to reinforce the walls and keep them from collapsing. These massive steel reinforcements will prop up the sides of the foundations closest to the subway and highways, preventing any dangerous cave-ins. But now that the foundations are secure, Nick's team runs into another problem. As they build the hotel on top and the foundations settle, the sheer weight of the hotel could damage the nearby subway line.
This is the metro tube. If we don't reinforce the area between the building and the tube, then we have a big problem because there's sinkholes and something like that. It's a lot of pressure for us guys.
The subway is in constant use. If the tunnel fails, it could be disastrous and bring transportation around the city to a screeching halt. In Amsterdam, engineers are building the biggest and most unconventional hotel in the Netherlands. Today, Nick and his team must construct a concrete barrier between the hotel's foundations and the nearby metro tunnel. This will protect the underground train line from the vast weight of the hotel above. They must expose a concrete ledge that sits a few feet from the top of the metro tunnel. This will form the base of their barrier, which is called a buffer plate.
It's important that we find it. We know it's somewhere there, so we must dig very carefully. Otherwise, we damage the metal tube and then we have a lot of problems.
It takes them an hour to unearth the ledge. The team now excavates around the rest of the subway tunnel, ready to pour the concrete barrier. Supervising the pour is Marcel.
It's an important day because this is the last part of the foundation, and the concrete plate we are making is to ensure that the ground won't push the metro line.
It takes a crew of 4 workers to pour the concrete. They get rid of any air bubbles with a vibrating nozzle and smooth it over for a perfect finish. It will take almost a month for the concrete barrier to dry to full strength. But it should prevent any movement between the hotel and the subway. Now that the barrier is in place, Nick and his team can start building up, knowing the subway and hotel are safely separated from each other. The main features of the hotel are the triangular sections that float in midair. These were inspired by an historic 1960s billboard nearby. But supersizing them for the hotel isn't straightforward.
In essence, it's 3 triangular volumes seemingly hovering on top of each other, only suspended by the core. But once you look at them in detail, how they have precisely been constructed, you see that there is a number of very, very clever tricks.
These clever tricks are called cantilevers. They are anchored to the building at one end firmly enough to support the entire overhang. The hotel will feature an ambitious 9 overhangs, each an astonishing 82 feet long. So Renier will have to push the innovation of his design to its limit. This is how he plans to do it. The tip of each triangular section reaches out a massive 82 feet without any obvious support. To hold up the colossal weight of the building above, on each floor, engineers build supporting concrete walls outwards from the central core that connect to giant concrete columns. They also secure 17-inch thick steel beams to each wall that support a super strong steel frame hidden in the walls and floor. This transfers the weight of the overhangs to the columns and the building's core, keeping the huge triangular sections floating effortlessly in midair.
The cantilevers, which seem enormous, it's quite a spectacular experience.
To build these unconventional cantilevers, Nick and his team must work with millimeter precision. Incredibly, they position the triangular corner points of each floor 1.5 feet higher than they should be, so the floors slope down towards the central core. Then, as they install the windows and walls on top, the extra weight should push the corners of the structure down to the correct position, making them level with the rest of the floor.
To build the big cantilevers, it's very important that we work very precisely. We talk about 1-2 millimeters. That's almost not possible. When it goes too far and the measurements are not right, that's a lot of work for us. A lot of time, a lot of money, and that's my responsibility. So yeah, it gives a lot of pressure.
Over the next 44 weeks, Nick's team painstakingly constructs the 3 cantilevers, making sure the triangular corner points sit 1.5 feet higher than the rest of the floor. It's only once the glass team starts installing the heavy windows that they can confirm whether or not the triangular sections will settle to the correct position. Architect Renier de Graaf is on site to inspect progress.
Initially, the floors went up, and then the weight sort of settled.
Yeah, we must make this one like 15 centimeters higher in the beginning than it is now. And in the end of it, it's a good result.
The whole thing looks amazing, and there's a lot of work still to be done. But from the outside, you now have the idea what the building is.
Nick may have impressed Renier, but the hardest part of the build is yet to come. It's springtime in Amsterdam. The construction of this extraordinary hotel is on track. But with doors opening to guests in just 10 months, Nick's team has to keep a strict schedule. And it's not just the cantilevers that he has to worry about. The ground floor of the hotel will be made up of a spectacular two-story lobby. A huge expanse of curved glass will surround this area. Today, workers are installing 4 crucial steel beams that will help support the 50 tons of glass.
Today, steel beams. We need that because the glass, what's coming inside, is very heavy.
Nick and his team have chiseled out holes where the 4 steel beams will sit. Each beam is custom built to exact measurements, so it's crucial they all slot in perfectly. Workers use a crane to move the first beam into place, then secure it at the top. But at the bottom, something isn't right.
It doesn't fit. Now we're gonna try to fit it again. Today, I must finish it.
In the Dutch capital of Amsterdam, engineers are building the country's biggest hotel. They're installing the huge steel beams that will support the feature glass wall at the hotel's base. But a key beam doesn't fit in the hole the team has made. They try to make the hole bigger, but it's still going to be tight.
It's Monday morning, always Monday morning. The first one doesn't fit. And I hope now we've done enough.
They widen the hole as much as they can, but there's still not enough room. They take the radical decision to cut the steel support as well.
A little bit cutting on the steel so it fits.
Finally, they manage to swing the beam into place.
Looks like it fits. It fits.
If the other 3 beams don't fit either, it will mean a costly delay.
Now we have 3 more, 1, 2, 3. I hope this one's fit.
It takes another 2 hours for the team to position the next 2 beams. The final beam will be the hardest to fit.
The last one is, I think, 1,000 kilo. So it's massive steel. They must be careful. This is the biggest of today, also the heaviest one.
Workers slowly maneuver the 1-ton beam into position. Thankfully, the base lines up with the hole.
This one fits perfect. That's what I say. I think the guys say something else. But
The team struggles to haul this hefty 1-ton beam into place by hand. They must position it perfectly, or the glass won't form a watertight seal with the frame.
it's struggling because it's very heavy.
After some brute force, a thumbs up from the top means they can secure the bottom.
Yeah, I'm very happy with it.
With the beams in place at the base of the building, Nick turns his attention to the next big challenge. He needs to install the 140,000 square feet of glass that will cover the triangular sections above. Today is a critical day. The team is gearing up to install the windows on the third and highest triangular section of the building. Windows specialist Jack supervises today's installation on the 21st floor. His first job is to lift the windows to a temporary storage space high inside the building.
The driver has to be very careful, because when they break some glass, then we have to restore it on the site, and that's very difficult and expensive.
Once inside the building, the fitters stack the windows as close to where they will install them as possible. They have to move fast. Installing a whole floor's worth of windows in just 8 days and staying on schedule is a massive challenge. This is how they'll do it. The team must fit 2,600 panes of glass in just 44 weeks. To speed up the process, a crane and specialized robot work in tandem. First, the crane delivers the huge panes of glass to each floor. From here, workers use a robot equipped with a suction arm to move each 660-pound pane into position outside the building. Here, workers reattach the crane and use it to guide the window into its aluminum frame. Using the crane and robot in tandem, the team should be able to fit an entire floor of 110 windows in just 8 days. On the 21st floor, Jack and his team begin their 8-day countdown. They work quickly, using the robot to move each window out beyond the building and turning it 90 degrees so it's upright. The team secures each frame to the crane, which then swings it into position. Workers above and below guide the window in and secure it into place. It will take 7 more days of breakneck work to install the 110 windows around each floor. The last window is the hardest to install.
The last element is always the most difficult element, because you don't have any space anymore.
They grease the rubber seals so the panel slides into position more easily.
Hopefully it will fit so that we can complete this floor.
The factory that manufactures these windows cuts each pane with millimeter precision. But this panel just won't squeeze into place.
It will not easily fit in.
If Jack and his team can't get this last panel in, they'll have to adjust all 109 windows on this floor to make room for it. A huge task. Today in Amsterdam, engineers are building the tallest and most unconventional hotel in the Netherlands. The window installation team is fitting the last piece of glass on the 21st floor. But it's a very tight squeeze.
The last 10 centimeters were a little bit problem. Now it's going in.
The window finally slots into place. Workers use bolts to attach it from above.
This floor is now finished, and we can go further with the next floor.
While the window teams race up the building, 21 floors below, foreman Nick is getting ready for a special delivery. Over a year ago, he built the main structure of what will become the hotel's extravagant lobby. Today, Nick needs to install 2 escalators into specific gaps left for them between the floor and the roof. Each escalator is 42 feet long, weighs 6.5 tons, and is worth $80,000. Moving them into position will be no simple task.
So the guys must be very careful.
2 forklift trucks, one at each end, must work in tandem to haul the escalators into position. It's a difficult and highly skilled job.
The second one is also coming. They are very big, bigger than I thought. Hope everything fits, because I did the measurements and it's the moment of truth, because everything fits. But yeah, in practice, you don't know.
To add to the pressure, the team must thread the massive escalators in between the steel beams that will support the ground floor windows.
It's very tight, a few millimeters. They must be careful that nothing is damaging between the steel beams or the escalators.
If workers damage either the escalator or the window frames, it could push construction back by months.
Oh. When it touches the steel, then we have a problem.
Inch by inch, the team hauls the escalator into position inside the building. Next, the fitters must carefully hoist it up. The big question, will the base of the escalator slot into the space? Only now will Nick find out if the measurements he made a year ago are correct.
You have here 5 centimeters space. So that looks good.
One down, but the second escalator will be even more difficult.
Second one is the hardest one, because there is less room for this one.
The team carefully squeezes the second escalator into place.
It's very tight.
After an hour of painstaking work, it's in position.
Perfect.
It fits flawlessly.
In the end of the project, we unpack it like a Christmas present, and it's gonna be perfect.
The escalators will remain in their wrapping to keep them pristine for opening day. "30 months after building began, main construction work is nearly complete. Nick's team must now race to complete one of the hotel's most striking features: the 2-story curved glass lobby windows. Today, the last 12 panes that will finish off the lobby's exterior arrive from Germany.
This looks very nice. There's no broken windows, so no broken glass.
A specialized glass fitting team run the installation. They have just one day to install all 12 panes.
If they're not finished today, then my schedule is a mess. So yeah, it must be today. First one was always tricky.
Each pane of glass weighs a colossal 1,300 pounds and costs around $2,700. The team uses a special suction crane to carefully maneuver each pane into place. A mistake would be disastrous.
This glass is special glass because it's curved. It's also expensive. It costs a lot of time to make this glass. So yeah, when we smashed one, I think then I'm 6-7 weeks at least.
Today, in the Dutch capital of Amsterdam, workers are building the country's biggest hotel. Foreman Nick is installing the massive curved glass panels that make up the base of the unconventional building. The glass panels must align with the steel beams and also sit perfectly upright.
The distance between every glass panel must be the same. And when it doesn't fix, for the eye, it's not looking good. It's also for the noise from outside. You have the highway and a lot of traffic around the building. When you are inside, it must be quiet.
Laat de hier gewoon. Kom, 1, 2. Hou je nog, maar straight. It's very important it's all straight, because when it's not straight, the glass is going to break.
Workers use metal connectors to lock each pane of glass into place.
If I have to be perfect as possible.
Over the next 4 hours, Nick and his team install another 10 panes of glass. They lay each one with the same millimeter precision.
The last one is the hardest one. This one, a very big one, very heavy one.
The last piece of glass is the most massive. They need to squeeze it through a tiny gap between the hotel and the scaffolding to fit it into place. To add to the pressure, the weather takes a turn for the worse.
I'm a little bit worried. The wind is coming up. Wind is too strong. We can't do our job today. And it's also very dangerous for the guys. So the guys must go quickly.
If the wind gets too strong, the pane of glass could act like a sail and crash into the scaffolding or the hotel itself.
Glas, helemaal van druk af. Ik sta erboven.
Zo zeker op de haro.
Uitschuiven. Rustig zakken, Klaas.
With a final push, the elite team battles the elements to wrestle the huge piece of glass into place.
The last one, not broken any window frames. So yeah, that's my motto. It goes very smooth. Now it looks very nice. Every day it's more like a hotel.
With the exterior complete, Nick's team can focus on the elaborate interiors. 19-year-old Vela is the youngest worker on site.
Hi, it's Vela. Being the only girl on the building, it's okay if you work hard and show you want to learn something.
It's Vela's job to inspect the interiors in every single one of the hotel's 650 rooms. Workers are already racing to complete the rooms in the hotel's lower floors. Carpenters, plumbers, tilers, and electricians have just 8 days to finish each floor, turning a concrete shell into 36 lavish hotel rooms. Before workers can move up to the next level, Vela needs to sign off on the floor.
It's my job to make sure everything is on track and finished on time. It's that important that we control and check everything.
Each time she spots something not to spec, she relays instructions to the relevant teams to make a fix.
The pressure is really high and it has to be good. The outside and the inside has to be perfect.
As the team races to finish the interior, spring turns to summer. The hotel has a glass skin, coating the 650 bedrooms. This amount of glass creates another challenge for the team. They must heat the building through the brutal Dutch winters and keep it cool during summer. To overcome this, engineers devise an ingenious solution that harnesses the area's unique underground geology.
Today we are drilling a big hole for a system to heat the building and to cool the building. What you're seeing here is Beta. It's one of the biggest mobile drilling machines in Holland. Always tell her she's pretty. Her teeth are extra hardened steel. She gets nasty.
It rests on the shoulders of Arjan to install the hotel's innovative temperature control system. It's called thermal energy storage. This is how it works. First, engineers drill 2 boreholes deep into the groundwater below. They can now pump water up out of these wells and back in. In the summer, they pump cold water up from one of the wells and use it to cool the hotel. In the process, this water warms up and they pump it back down into the other well. This creates a reservoir of hot water, which is so well insulated that it stays warm until winter. Now, engineers reverse the flow, pumping the warm water back up to the surface to heat the hotel.
It saves a lot of money. Yeah, it's the future.
Today, Arjan and his teammate Henry are drilling the 580-foot deep borehole that will contain the warm water. Even with their big drill Beta, this is no easy job.
This is the big pump of Beta. I love the sound of 500 horsepower.
As Beta drills, she sucks up the earth and spits it back out into large containers.
The pumps are sucking the sand and the water up. It comes in our 3 containers and material will drop down.
The drill then pumps water back into the hole. It's vital they get the speed and pressure just right. If the sides of this massive borehole cave in, the results would be disastrous.
It's very dangerous. If in the worst case, the drilling hole would collapse, this might be the next Tower of Pisa.
Today, in the Dutch capital of Amsterdam, workers building the country's biggest hotel have reached a crucial stage. They're drilling the boreholes that will house an ingenious thermal energy system to regulate temperatures in the hotel. To prevent the hole from caving in, they must line the first 100 feet with iron casings.
Showtime!
This is a precarious operation. If the team inserts the casings at the wrong angle, they could puncture the side of the hole.
In a worst case scenario, when you scratch open the side of the borehole, a big sinkhole could appear. That could be a disaster.
In the end, it's a success for the team. After just 48 hours, Arjan and his teammate Henry reached their target, nearly 580 feet below the surface, and complete the temperature control system. There are now just 6 months until the floating hotel is due to open to guests. Inside, the interiors team races up the building. Designer Fernando Ispethua is in charge of making sure the hotel's extravagant bedrooms look as striking as the design outside.
As the building itself is really beautiful, so that's the reason why the whole interior design is quite crazy.
The hotel's cantilevers are a unique layout for Fernando to work with. Each of the triangular corner points face a different point on the compass, and the rooms are themed to match.
Here we have 650 rooms and we have 6 different themes, so with different cultures, mixture of cultures.
The bold design continues in the communal areas. Fernando commissions local artist Bara Verkeka to cover the walls of the main reception and bar.
The design is like thinking out of the box. Hotels, they go for safety. Then here, what you see is this colorful explosion of art everywhere.
It's late summer. In just 20 weeks, the hotel doors will open to guests. Work on the bedrooms and communal areas is almost complete. For Nick and his team, completing this 650-room hotel has been a monumental challenge. Over the last 38 months, they have removed 2,500 trucks of soil, poured 70,000 tons of concrete, installed 11.5 million pounds of steel, hung 2,600 windows, and positioned 650 beds. The end result is a masterpiece of modern design, a bold new icon in the heart of historic Amsterdam.
Everybody talks about it and you can see it from miles away. I'm more than proud of it.